imagine that we have an application that's going a little haywire. And we don't necessarily realize this. This happens sometimes with applications. I'm going to copy this code. I'm going to open a new session, paste it in, and uncomment it. What's happening with our application is that it's trying to make some updates, but something is failing and the updates aren't committing. It's hitting an exception and they're rolling back. I have done this in a really, cheap and easy way by manually putting in a rollback command, but imagine that they're hitting some sort of error in the business logic. Maybe it's a longer transaction than we have here, but sometimes we get these situations where our application tries to do something, it hits a validation problem and it has an exception and the whole thing has to roll back. So we're just simulating that here with some updates that I have this cheap and dirty go command saying run this 100,000 times so that this will just be constantly happening in the background. The way that people get into NOLOCK is that the most common cause, the most common gateway to using NOLOCK is that people see lock weights. Imagine that we also have something else in our application that's constantly tracking what is the sum of the total count of babies here. And it takes that total name count column, the same one that is being updated by our application, it takes that column and it sums it up across the whole table. Now, ref.firstname is not a very large table, so we're going to have to scan this table, but it's a small table. What this block of code is doing is it's creating a temporary table named name count, and 200 times it's going to sum up that total name count column and return the total names. It uses some date diffs to just capture a rough count of seconds of the duration of how long it takes to do this 200 times in a loop. So we don't have any hints on our query. Our query for this first run is just selecting the sum from the table. We are using the default isolation level of read committed. I haven't changed my default isolation level in this database to use any optimistic locking or anything. I'm using the default when you install SQL Server yourself of read committed. Different in Azure SQL database. That's the one place where it installs differently, or I suppose it is installed for you and uses a different setting now. All right, so let's get this going. And what happens often is what people see is they get a report that things are slow and they open up something like the built-in activity monitor in SQL Server to say, okay, I want to see what activity is going on. Activity monitor isn't perfect. It isn't going to show us everything. It isn't even going to show us all types of our weights. It shows us resource weights. It won't show us pure CPU weights, but we can see, looking at this, my script has already ended, but I can see that I have recently had lock weights on my SQL Server. I haven't had any other weights, but I've recently had these lock weights. And if I run my script again, the first time it did the count 200, it did that sum from first name. It did it 200 times. The first time it took 18 seconds to do that. Let's run it again. It'll recreate the temp table. And while it's running, we can see that we have active, lock weights on our SQL Server. I have 131 milliseconds of lock weights. This isn't a huge amount of lock weights right now, but if I'm looking at, hey, I want to speed up my SQL Server, my weight stats are indicating there is a number one area that you should look. My reads finished again. It took 17 seconds again. And this normally, if I'm not running a lot of other stuff on my laptop, takes 11 to 12 seconds. I'm having a lot of resources on my laptop in use, so it's consistently taking 17. Let's run it a third time and see if we can figure out what queries are involved using that activity monitor tool. Like I said, it's not perfect, but it does give us some information. I can see that the command with a lock weight, specifically I get the weight type at this time. It's waiting for a shared lock weight this time. It is an insert command. And I can even, if I catch it when it's happening, let's run this one more time. It took 16 seconds this time. If I catch it when it's happening and when it's being blocked, Let's see if we can get the lock weight here. Here's our insert. There we go. Now we have our lock weight there. If I right click and say details, I can identify, hey, it's this select who's having these lock weights. And the way that people get into NOLOCK is they find things are slow, they see that there's someone being blocked, and they do an internet search. How do I get rid of blocking? And one of the things that you'll find on the internet is that one way to get rid of blocking and to speed things up, right? If blocking is making me slow and I can get past the blocking, I'm going to be faster generally, right? So legitimately speed things up is to add a NOLOCK hint. So this one is taking us 16 to 17 seconds with our current activity on the host of our virtual machine. Let's look at the counts that we got before we add any NOLOCK hints. We've got our application going kind of haywire in the background, and it's trying to update things, right? And it's rolling them back. Under read committed, every time we counted, all of the 200 times, we got the same answer. Read committed will only read committed data. This data in the other tab, it's going haywire and it never commits. It rolls back, it does the updates, and then it says, oh, I've got to go undo them. It never commits. And read committed, it says, okay, if you're not committed, I will wait. If you've got a lock and you're not committed, I will wait for you faithfully, so that we did always get the correct answer for the committed data. Let's add that NOLOCK hint. We want to speed this up. So we make one change to our query and we add this table level hint that says, I want to use read uncommitted against ref.firstname. We're still doing 200 runs. We're still, checking our time before and at the end. Everything else is the same, and we're recreating that name count table. I'm going to drop that table and run this. And let's look at Activity Monitor while it runs. Let's look at our weights. We don't see any lock weights at all this time, right? I have backup weight as my top weight here. Lock is down here and it's got zeros for its wait time and recent wait time. It looks like we solved the problem and the duration of our query was faster. This wasn't 16 or 17 seconds this time. This was 10 seconds. This is how NOLOCK ends up staying in the code and starts proliferating because I added NOLOCK and it got faster. It's sort of like we got a reward, which makes us want to use it again and again and again. It was an easy fix. It worked immediately, but it does have some problems. Let's look at the data that we got this time. When I ran with read committed, all 200 times that I counted, I got the same name count, which was just the committed name count. When I used NOLOCK, otherwise known as read uncommitted data, it doesn't matter that that data in the other tab never committed. It doesn't matter that there was a problem and that data never landed in the table. Whatever state the data was in, we said, okay, I'll just count it up. So we got 6 different answers for how many babies are in the United States. And it may be that if we currently look at the state of the data right now, there's less babies, because this is the number of babies born, right? We might end up with a report that says there's a higher number of babies born, and then they run it again in 2 minutes and the number is lower. Well, how did that happen, right? The data will just look like it's totally wrong if we are returning uncommitted data to our users and they don't understand that we are reading data that has never been finalized or accepted as committed inside the SQL server.